We're doing the example in section 2.2 on standard deviation. And what we're going to do today is we're going to go through and do this one example by hand so you can see what's going on. You can see the magic of the calculator and how it finds what's called standard deviation. What do we have here? Test scores for two students. What are their names?
Connie.
And?
Oscar.
Okay. Do we know their averages? Their mean?
Yeah.
They're both 84, right? Let's write that at the top. Connie, we'll call X bar. 84 is her average. Oscar, Y bar, 84 average. So their test averages are the same. They are the same student if you just look at the mean. There's another measure of statistics that tells us how consistent they are, and that's called the standard deviation. Here's the process. First, you have to go through and find each student's test deviation from the mean. So when they ask you to do this on the green worksheet, finding the deviation from the mean, you have to find multiple answers. Connie's deviations from the mean are 82 minus 84. These are all her x's. This is x minus x bar. Some of them will be positive, some of them will be negative. What's 82 minus 84? 86 minus 84. Continue with the column. So she deviated 2 points below her average, 2 points above her average, 2 points below, right on her average, 1 over, 0, and 1 over again. Would you say she appears to be kind of consistent? I think so, especially when you compare to Oscar. When you do y minus y bar for him, what's 72 minus 84? Negative 12. He was 12 under his average that time. 94 minus 84, 10 above. Continue with the column. 76 minus 84, 8 under, 12 over, 6 over, 8 under, right on. So you can see right away he's less consistent. So what do you expect his standard deviation to be? Bigger or lower? Bigger. Bigger than Connie's. Very basic, straightforward example. Let's assume these are all of their test scores. If these are all of their test scores, it represents the whole population of test scores. So we're going to use the sigma x and the sigma y. All right? And that formula goes a little something like this. Now that you've found all the deviations, here's what the formula does next. Here is the formula, by the way. Okay? So we've already done this part. I'll highlight what we've already done. We've done all the deviations. Now we need to do what to them? Square them all. Everything's going to turn positive now. Negative 2 squared is positive 4. 2 squared, 4. Negative 2 squared, 4. Keep going. You square the deviations. Do the same for Oscar. Whoa, 144, 100, 64, 144, 36, 64, and 0. Can you see right now why we're probably going to get a bigger answer over there? We're using bigger numbers. The next step is to do the sigma. What does sigma mean in math? Sum. We add these numbers and add these numbers. It's amazing sometimes when you think about it that the calculator does this in under 1 second, right? This is how long it takes. No matter how big the data set is, it can pretty much handle it. All right? Well, let's go. 4 plus 4 plus 4 plus 1 plus 1. 14. That's the sum of her deviations squared. His? 3. What do you got? 550, 552. Put that number over here next to my formula. Remember, this is the formula that we're working with. Finally, we divide by how many data items there are. Since this is the entire sample, we're going to divide by all of them. How many are there? Wait a minute. Let's read the top again. Consider the two students whose scores for 10 assignments are listed below. Notice that Connie's mean score is 84 and Oscar's mean score is 84. Do you think this is a sampling of the 10 scores? Then we're going to use, yep, this is a sampling of the 10 scores. Okay, so we're going to divide by n minus 1. All right, so how many scores were sampled? 7 are in the list, right? 7 actually made the list. So what should we divide by? Go ahead. Divide by 6. So you take hers divided by 6. What do you get? 2.33. That's known as the variance for her. Repeating. Take his total divided by 6. 92. Right on the button. Standard deviation is the square root of each of these. Square root 2.33, square root 92. That's the standard deviation. $1.5. Let's just go with 1.5 for her. For him, sorry. $9.6. So let's analyze our results. Were we right in saying that he's less consistent because his standard deviation is higher? Could we say something like this? On average, Connie's scores are about 1.5 points above or below her mean, while Oscar's vary like 10 points above and below his mean. That's how to interpret standard deviation. Good night and good luck.